In this lesson, we are going to talk about writing an equation of a polynomial given the function's zeros. As you can see in the title of the lesson, zeros is next to solutions and intercepts. And that is because in the lesson we're going to be talking about, you're going to see those different terms mentioned below. For example, in example 1, it uses the term intercepts. In example 2, it uses the term solutions. And in example 3, it uses the term zeros. So what you need to know about those is those three things mean the same thing. A zero is the same as a solution, and that is the same as a intercept. Before we get started in the lesson, I want to go back and review a couple of things. First off, if I gave you the equation x squared minus 3x minus 4, and I asked you to factor that, you would give me x minus 4 and x plus 1. If I asked you to solve that, you would then tell me that x equals positive 4 and x equals negative 1. In this particular lesson, we are going to be going in the opposite direction of what I just did. So instead, we're going to be starting with the zeros, creating the set of parentheses, and multiplying those two sets of parentheses, or 3 or 4 sets of parentheses together to get the polynomial. Let's review the steps that we have listed below. Step 1 says convert all of the zeros to factors. We do this by something called reverse solving. Let me demonstrate what I mean. If I told you that the zero was x equals 5, and I reversed that process, then that would mean that would come from x minus 5. Simply, if I solved x minus 5 and I set that equal to 0, my solution would be x equals 5. So by reverse solving, I can get the set of parentheses that created that solution. Let me show you another one. If I give you x equals negative 2, and I reverse that process, I would have x plus 2. Essentially, what I'm doing again is bringing that number back across the equal sign. The second step in this process is multiplying the two factors together. So I'm going to be taking those two factors, and I'm going to be maybe using box or FOIL, depending on what you're comfortable doing. I prefer that you use the box method to keep extremely organized in the process of these equations. There's going to be a lot of terms that get combined together, and the more you stay organized, the less mistakes you're likely to see. The last step is we're going to combine like terms, and we're going to write it in descending order. Descending order means that the polynomial goes from the highest power down to the single number. Let's take a look at this first example. In this first example, it is giving me the following intercepts. X equals negative 4, x equals 1/2, and x equals positive 3. What I want to go ahead and do is I want to do step 1 and reverse the process of those to find the factors. So if I'm starting with x equals negative 4, the parenthesis that I would need to create that solution, I would get by reversing that, and I would have x plus 4. In the second one, I have x equals positive 1/2. Now, it might make you think that if I reverse that I'm going to go ahead and just put x minus 1/2. Except we don't want to do that. We don't want to write a fraction in the set of parentheses. So what we want to do is we want to come up with a set of parentheses that would give us this as a solution. When you think about this, it makes more sense to go ahead and bring the 2 over first and then subtract that 1. So something like this, if I solved that, would give me the solution of 1/2. Again, I don't want it to include a fraction there. I want it to be something that if I solved it, it would give me the fraction. So I'm going to make a note of that. No fractions in the factor. And lastly here, I have this x equals 3. Again, if I reverse that, that would give me x minus 3. Again, we're bringing it back across the equal sign. So essentially what it's going to do is it's going to change the sign of what that solution is. So what I did there was, again, I converted the zeros into factors. And the next step is going to be multiplying these. What I'm going to go ahead and do is start with multiplying 2 of these together. Now, I really highly recommend that you keep very organized with these. So I'm going to come off to the side and I'm going to do the box method. Now, I do not require you to use this box method, but again, the thing about the box method is it always gives you the exact terms that you're going to need when you put these groups together. When I fill in this box, I'm going to have 2x times x, which gives me 2x squared, and 2x times 4 is 8x, and minus 1x, and a negative 4. So when I put that together, I can combine these diagonals together here, and that will create that particular section to become 2x squared plus 7x minus 4. What I'll need to do now is bring down that other factor next to this. Again, to keep very organized, I'm going to go ahead and do a 3 by 2 box to multiply those last two together. Now, you're welcome to go ahead and do the distributive property if you'd like. If you're going to do the distributive property, you're going to take the terms from the first and you're going to multiply them to both and then just move through the set. But again, keeping very organized with these terms allows me to know that I'm not missing something when I go through that multiplication. As we fill in this box, I'm going to get 2x cubed, 7x squared, minus 4x. In the next row, I'll get negative 6x squared, minus 21x plus 12. Now, all of these little steps that we're doing are things you've already done in other sections. In the last section of 3.1, you did a lot of multiplication of these polynomials, so we're doing something very similar in these examples. As we group all of these together and we write it in descending order, I would have 2x cubed plus 1x squared minus 25x plus 12. Now, if you like to leave that 1 there, you can. If you'd prefer to not write the 1, you could simply just leave that off and just have a single x. So again, let's just take a second and review what we just did. If you need to pause the video and copy that example down to finish it up, please go ahead and do so at this time. But as you can see, what we started with was taking the zeros or the intercepts or those solutions, and we converted them into factors. Then we took those factors and we multiplied them together. And then we took those and multiplied those together to get our final polynomial. These steps are going to be the same regardless of how difficult these problems start to look. And they are going to get more challenging as we move through this lesson. Let's go ahead and take a look at this next example. You'll notice that these solutions just look slightly different from the ones that I had before. You'll see on this one it says x equals plus or minus 2. While that looks confusing, what that means is I have x is equal to a positive 2 and x is equal to a negative 2. Over here, I have x equals plus or minus I. What that again means is that I have a positive I and I have a negative I. Now, I know upon initial look that might look challenging, but let's follow the same strategy that we just did from before. Here, we're going to say x minus 2 because we're going to reverse that process, again, moving it back over that equal sign. Here, we're going to reverse this one and make that x plus 2. Here, we're going to have x minus I, and on this one, we're going to have x plus I. Now, all of these are going to end up being multiplied together, but I highly recommend that you keep these very organized and that you multiply like groups together first. Now, like I said, we're going to end up multiplying all of these together at one point. But if you start by multiplying maybe these two together, the problem will become much more difficult. So let's start by going over here and multiplying x plus 2 and x minus 2. And while we're getting these set up, I'm going to remind you that these two sets of terms, those are called the conjugates of each other. And as I start to multiply through this box off to the side, you're going to notice that something's going to begin to happen. Anytime that I multiply the conjugate, these diagonals are going to cancel out. Now, I made a slight mistake there on that one. I put an x on the end that didn't belong there, so I'll take that one off. And you can see here, these diagonals are going to cancel out. And so this particular set of parentheses will give me x squared minus 4 when I put them together. Now that was pretty easy because it was just numbers, so I'm going to move to the next one and we're going to talk about the next step. So x plus I times x minus I. Now I'm going to come all the way back up to the top and make a note here just for our kind of reference. Remember in the last chapter that when we multiplied two i's together, we got I squared. And I squared, if you remember, equals -1. This is going to be very important in this lesson as we move forward. Let's go back down to that problem we were working on. When we multiply through, we have x times x, which is x squared. Here we have ix or xi, it doesn't matter how you write it. In this one, we'll have negative ix. And in this box, we're going to have negative I squared, which means I'm going to have a negative. Remember, I squared is equal to -1, so I'm going to have a negative -1, which becomes a positive 1. You can see here in this one that these diagonals are going to cancel out because you are multiplying two terms that are the conjugates of each other. So these two together will make x squared plus 1. Okay, so now I have these two. Now, I have them kind of far apart, and it might help you maybe to set them next to each other, closer together to help it make sense of what you need to do next. But the next step would be to multiply those together. Now again, you certainly could use FOIL. You could have x to the 4th plus 1x squared minus 4x squared minus 4. So that would be using FOIL maybe to put those together. And when I'm multiplying a two-termed polynomial times a two-termed polynomial, it could even be easier to do that. But again, maybe it's helpful for you to put it back into the box and multiply those together. So here for this one, I would end up with x to the 4th minus 3x squared minus 4. Again, take a moment and pause and get that example copied down and make sure that you have all of your terms correct. And then go back over and kind of make sure that we followed those 3 steps. First, again, taking those factors and converting them into those sets of parentheses. Then taking those sets of parentheses and starting to multiply them together, and then finish the multiplication up. All right, as we look at this last and final example, it's just going to give you different sets of zeros. But you'll notice this particular problem says a fifth degree polynomial. Well, that's probably something you haven't heard before, but what that means is that your final answer should be left with x to the fifth. When you look at your sets of parentheses, it also means that you should have 5 sets of parentheses when you get ready to get started. So here I have x equals 1/4. I have x equals plus or minus the square root of 10. I know that looks different, but just hold on and we'll go through what that looks like here in just a moment. And last we have x equals plus or minus 5i. Now remember, we have x equals 1/4. We have x equals a positive square root of 10 and x equals a negative square root of 10. We have x equals positive 5i and we have x equals negative 5i. Here are those 5 different solutions that are going to create 5 different sets of parentheses. If we start here on the back end and we reverse the process, that would give me plus 5i. Reversing this one will give me minus 5i. Reversing this one will give me positive square root of 10. Here I'll get negative square root of 10. And on this one, it's very similar to the one we had before. Remember, we don't want to write x minus 1/4. We want to create a set of parentheses that if I solved it, it would give me 1/4 as my answer. Now, in the last problem, I mentioned multiplying like groups together first. So I'm going to take these two that are similar. I'm going to use the conjugates of those and multiply them together first. So I'm going to have one 2x2 box, another 2x2 box to use those. So I have x plus the square root of 10 and x minus the square root of 10. Okay, and that's going to give me x squared positive square root of 10x. Don't be alarmed at what that looks like. Just fill it into that part of the box method. Here I'm going to have negative square root of 10x. And this here, I'm going to have negative 10. Now, if you're wondering, how do I get that? That's because I'm taking a negative square root times a positive square root. And remember, when I multiply two square roots together, it cancels it out. It's almost like saying the square root of 100 equals 10, because essentially I would have 10 times 10, which is 100. So I have negative 10 there. Now, just like we talked about before, I just multiplied the conjugates, so those diagonals are going to cancel, and it's going to leave me with that particular group here of x squared minus 10. Now, I'll do the same thing. X plus 5i, x minus 5i. And if I multiply here, I'll have x squared 5ix, again, that's just a formality. It could even say 5xi minus 5ix. And then here I'm going to have a negative 5i times a positive 5i. So I'm going to have negative 25i squared. Now, that's negative 25 times negative 1, which is going to end up giving me a positive 25. Reminding myself that that diagonal on this one is going to cancel out because I'm multiplying with that conjugate. And when I group those together, I'll have x squared plus 25. Okay, and then I can bring this last group of parentheses down. Now, here's where I have a couple additional ones that are like groups. So I'm going to go ahead and combine those together. If you needed to come off to the side and do another box, that's fine. I'm going to go ahead and multiply those kind of in my head. So I'm going to say first gives me x to the fourth. Outside and inside, That's going to give me 25x squared, and then the inside would give me a negative 10x squared. So that would actually end up giving me a negative 15x squared. Well, of course, then I'm going to have negative 10 times 25, which would give me negative 250. Now, if that's confusing, and I know we're running out of room here, but if it would help you to put that into a box and multiply x squared minus 10 and x squared plus 25, then go ahead and go through that process. Don't shortcut it if it's helpful to you. If it's helpful to you, then do the extra work that you need to make sure that you're getting that answer correct. Now, we're not quite finished. This is one of those ones where I have a lot of different terms to worry about. So I am going to go ahead and go through the process. 4x minus 1, x to the fourth, minus 15x squared, minus 250. And I'm going to distribute all the way through this row to get 4x to the fifth, minus 60x squared, minus 1000x. In this row, I'm going to have negative x to the fourth, 15x. Now, wait a minute, I made a little mistake back here, so let's go back to that. I didn't pay attention to this one here, where I actually had x to the third power in that second spot. So if I take this, I'm going to change that to a third power there. All right, so I have that back to a third, which makes this x squared. Okay, then we're going to come down here and we're going to have a positive 250. Now you might think, well, Mrs. Anderson, how did you know that you caught that mistake? You should go in descending order, and with a situation like this, you never should have the same power within the same row here. And that would have given me a squared and a squared, so I should have known to go back and check that. So here I have 4x to the fifth minus x to the fourth. This is going to be a long one. 60x cubed, 15x squared, 1000x plus 250. So I have a very large polynomial there, a lot of multiplication happening for this problem. But I've stayed very organized, kept everything nice and neat to get my end result. Again, take a second and pause that video to make sure that you have it all copied down and that we didn't make any mistakes as we are going through. What you should do is use these notes that we've just taken here as you get ready to start the problems that you're working on. They should follow very similar ideas as you're going through them. Just remember that when you're given the zeros, that you're always moving them back across the equal sign. Because what you'll end up with is a mistake if you're not changing the sign. So again, if this is starting as a negative 4, then it should be a positive 4 in the parentheses. This is starting as a positive 1/2, so I should have a negative here. Ending here as a positive 3, so it should be a negative. So that should kind of help you as you're going through this. All right, go ahead and use your notes now and work on the homework assignment.